Alright, so here we are with Chapter 6, Day 4. So potentially, again, Chapter 6, Day 4. Talking about odd and even functions. So, interesting part about even functions, at least algebraically, is if you plug in a negative x, so as we've done with composite functions, for instance, we've plugged in one function into the other. So here we go, plug in a negative x and simplify. If you get the original equation back out, so for instance, maybe there's a squared in there, and because it's a negative inserted, that squared would then cancel that negative, and now you end up having literally the exact function come back out once you simplify. That means it's an even function. If it is an odd function, you actually do all of this simplification and realize that you get the negative or the opposite of the entire function. So every addition has now become subtraction and vice versa. So just make that a nicer x there. Okay. So again, for this first one here, the result is the original function multiplied by -1. And then the other one, if you have an even function, plugging in that negative x, the result is the original function. And so this is what we would call the algebra options of identifying something as even or odd. Alright, then we have identifying something as even or odd by a graph. So if you see that the graph reflects over the y-axis, you have an even function. If you see that the graph reflects across, rotates 180 degrees about the origin, so 0, 0, then you actually have an odd function. So again, this is via a graph. And then the last part is, let's see, what color haven't we used, is talking about if you have an even power or an exponent. And it could be powers or exponents. Or, of course, an odd function would be if you have odd powers or exponents or degrees. And so we'll call that kind of the equation idea. Alright, so now that we have all of those to identify what's happening, we're going to do an even example and an odd example. So here's our even function example. We've got x squared minus 2. Super. So algebraically, let's say I did that in purple. So algebraically, I'm going to go ahead and plug in a negative x. So I'm going to take this equation, f, and I'm going to plug in this negative x. And so if I plug in that negative x, instead of x squared, we have negative x, and then the minus 2. Alright, so what does that mean when we're simplifying? That means that this here is actually negative x times negative x. And so you end up with a positive x squared minus 2, or x squared minus 2. Which is f of x, and the original was f of negative x. And so because of that statement, f of negative x equals the original function, it's even. Alright, so the next piece, of course, is going to be via the graph. So if we take a look at the graph, and this one I was doing in blue, all you need to do is plug in your x values here for the function, the original function in for x. So we're going to square each of those and then subtract 2. So negative 3 squared is 9, minus 2 is 7. If you plug in a negative 2, you get 2 back out. Negative 1, you get negative 1. Negative 2 for a 0. 0 squared minus 2. And then it kind of goes back up again. And so taking a look at what we have here, our first one is negative 3 7, so that's over here. Negative 2 2, negative 1 1, 0 negative 2, oh, negative 1 negative 1. I was wondering why that was a little off. 1 negative 1, 2 2, and then 3 7. Okay, so if we take a look at this guy, alright, we're looking for, does it reflect over the y-axis? And so here's our y-axis. And it most definitely is a mirror image. I mean, if I could draw a nicely curved line there, of course, mine looks a little jogged, but... and then the last piece, of course, is actually looking at the equation itself. And remember that the equation is x squared minus 2. And so we realize that we have a power of 2. And so because of that, we could identify that it was even. So there's 3 different ways of figuring this out. Again, we could have done it algebraically. We could have done it graphically. And then also via its equation. Alright, the next one is our odd function. And so our odd function, just like the previous, we're going to try to plug in a negative x. When we plug in a negative x to this equation, we'll have negative x cubed minus x. And so both of those will now have a negative x inserted. Negative x cubed becomes negative x times negative x times negative x minus a negative x. Oh man, that's intense. And of course, minus a negative becomes plus. So we have plus x for this section here, and then a negative times a negative times a negative results in a negative x that's been cubed. So if we take a look at all of what results here, we actually have f of negative x becoming negative f of x. Because again, the original, if I applied a negative, would have become negative x cubed plus x, which is what we got here. So that means that we have an odd function. Alright, then we move on. Looks like OPD. Anyway, odd. Okay, so then we move on to graphing, and so if we plug in each of these values, negative 3 to the power of 3, and then minus negative 3, so plus a 3, leaves us with negative 24. Plugging in negative 2 becomes negative 6. 0 for negative 1, 0 for 0, 0 for 1, and you're like, what? But we'll talk about that in a second. And then 6 and 24. So graphing those, we clearly can't graph the negative 24. So we'll start at negative 2, negative 6. Negative 1, 0, and then we end up with a 0 here and a 0 here. And then 2 up at 6 again. So what actually happens when you look kind of at the minute ideas, of course this goes up at the end and this goes down at the end, or at the beginning, but then we go through this axis, back up and down, and through this axis again. So it kind of does this snake-like idea. And because of that, you end up having this point of rotation that you could rotate around or halfway around 360. So if we could rotate 180 degrees, we would end up having the exact same equation again. So rotational symmetry means that it's odd. And then the last piece, of course, is the equation. And as you can see in the equation, our function has x to the power of 3, and then also an x to the power of 1. And so because both of these are odd powers, or odd exponents, we end up with an odd function. So that is how you identify. And what we normally would have done, but we're kind of at the end of the block, is you would have had an assignment that kind of practices this. So what I'm going to do is actually pick a few from the problem below in order to kind of see what's happening here. So the first one I'm going to try is, nope. We'll try number 7 here. So if you're on that handout here, we're going to go to number 7. So notice we have a rational function, so hopefully that's something from last block that you kind of can identify with, or sorry, last chapter. So, is it even or odd? Well, let's go ahead and explain with algebra or a graph. Sometimes the algebra, depending on how good you are at understanding squareds with negatives, is not as easy. So I'm actually going to just jump to a graph. So if I jump to the graph, plugging in -3 through 3, I have done this already, so I'm copying from the table in my calculator. So 0.1, 0.2, 0.5, 1, 0.5, 0.2, and 0.1. And so hopefully just even with the chart itself, you can see that it does center along this y-axis at 0. And so that would mean that it's hopefully even, but let's see. So first thing I'm going to do is do 0, 1. That's kind of the most whole number idea. Then the next one is -1.5 and 1 with a half. And then after that, it kind of goes down towards 0. So hopefully you can see that our graph is going to kind of follow along here and then reflect on the y-axis. And so because it reflects on the y-axis, we now know that it is even. Now again, you could have looked at the power and said, oh, well, there's a squared there, but did we talk about if it was on the bottom? And so sometimes it's easier to use that algebra or use that graph to kind of state for sure that it actually is. Alright, so let's see which one we want to do next. Alright, the next one I'm going to try is number 4. So number 4, we're identifying if it's even or odd, and now you can look at the power and you're like, well, the power is a variable, so it's very hard to tell what's happening there. And so again, it's a lot easier to do the visual, so I'm going to go ahead and graph. So if I graph and plug in a -3, the answer is 0.125. The result from plugging in a -2 is a fourth, or 0.25. -1 becomes 0.5. 0 is 1, 1 is 2, 2 is 4, and 3 is 8. And so taking a look at what we have here, it's probably easiest if we start with the larger numbers. So over 3 up 8, over 2 up 4, over 1 up 2, over 0 up 1, -1 is at a half, and then after that my pen doesn't really quite work. And so we end up with this exponential equation. And so hopefully you can see that it does not mirror or a reflection on the y-axis, and it also doesn't rotate. And so if you noticed the name of our section here, we could have odd, even, or neither. And so in this case, 2 to the x is actually neither, which is an option. So not everything's odd, not everything is even. There is that kind of mid-point halfway through there. Alright, and so the last one I'm going to do is number 9, again kind of looking at these rational functions. If you go to our previous rational function and this idea that there was a squared in it which made it even, if I look at this one there is a power of 1, and so I might guess that it is odd, but I do want to verify and explain my choice. So how I'm going to do that is, again, a graph, and of course I could do... Well, actually, I'm going to not do the graph this time. I'm going to do the algebra. Why not? So, in that case, I'm going to try to do f of negative x. So that means that I'm going to write the f function, which is 7 over x, erase that x, and plug in a negative x. So what does that mean when we're thinking of simplifying? That means that we actually have 7 over negative x, or technically, depending on how you write your negatives, negative out front 7 over x. And so really we have taken the entire equation, f of x, and made it negative. And so because f of negative x has become negative f of x, we now have an odd function. If we had graphed it, we would have noticed that if you kind of put your pencil on 0, 0, it would have rotated 180 degrees and then been on top of itself again. So would have had a good visual there as well. So if you feel like doing the rest of them, most of them are either even or neither at this point. There is one more odd. So if you'd like to go through and graph x, negative x squared, or this parabola here, number 8 is linear, and then 10 there we have an absolute value. But that was just an introduction, again, to odd and even functions, day 4 of chapter 6.